Philip Russell, a British physicist and pioneer in light.
To be creative, you need to be able to think for yourself and not pay too much attention to what other people say.
He's director at the Max Planck Institute for the Science of Light and professor at the University of Erlangen-Nuremberg.
In a sense, be a little bit crazy is not a bad idea, but in a good sense, of course. Good crazy, not bad crazy.
He's considered a leading authority in his research. To him, freedom of thought is the most important thing.
It's like exploring a new country that no one's been in before. Because nobody's been there, you don't even know what's there. But once you've landed in the country, you can start to explore it. So this is a bit what it's like. With these fibers of mine, that's what it was like.
In 1995, then at the universities of Southampton and Bath in England, he and his team were able to achieve a breakthrough. Thanks to his clever idea, the first glass fiber with a micron-scale inner structure was realized, the structure of a photonic crystal. Philip Russell is fascinated by light and by sound.
You can hear up here that the fiber is very fragile. Yeah. It was down at the bottom when it was thick. It was much more.
His composition has had an enduring impact on the worlds of science and research. Since then, Russell has been working on the improvement and advancement of the photonic crystal fiber and other structured fibers.
This is a whole stack of capillaries. That's what we make in the drawing tower. They're stacked together very carefully in a clean room. The idea is that we take this structure and we make it much smaller by pulling down the glass. And if things work out correctly, you can go from a structure like this to something maybe 10 times smaller, which contains the same geometry, the same structure as you built by making a stack before. And then we draw this one down again by another factor of 10 or so in dimension to the final fiber itself, which is something about this kind of thickness.
The almost miraculous tool is useful not only as a light source. High-precision measurement of chemical reactions is possible thanks to differing fiber structures or detecting minuscule quantities of substances in gases. No matter whether dealing with light, gases, or liquids, every new bundle of glass fibers delivers the raw material for new developments.
This solid core fiber has proved to be very, very useful because if you put short pulses of laser light into the core, you can then generate what we call a supercontinuum of light. This is you can generate all the colors in the rainbow and in the ultraviolet and the infrared just with a single pulse of invisible light. It goes into the core, and through the interaction of the light, of the infrared light with the glass core, one can generate this broadband supercontinuum. You can generate basically sunlight from a single pulse, and very, very, very bright.
The spectrum of sunlight in its entire range and beyond can be generated by a single laser pulse. Such ultra-short flashes of light would destroy every other fiber. And if it were up to him, this would just be the beginning. This recipient of many awards never seems to run out of ideas.
What you see here is a setup where we're exploring the properties of a new design of fiber. What we're doing with this fiber is twisting it. So if you go along the fiber, instead of it just staying in one orientation, it's actually twisting as it goes. So it's like a spiral. The whole thing spirals as it travels. And what this does is something really beautiful. When you launch light into the fiber, it puts a twist on the light. And in fact, that can be used to if you put light that has a spin on it and focus it onto a particle, you can make the particle spin.
The applications are virtually unlimited in medicine, biochemistry, astronomy, or environmental research.
There are different modes of this fiber, and each of them has a different amount of angular momentum. And so you can distinguish these modes from each other and use each of them as a channel, potentially, in telecommunications.
At the start was an idea, one that never let him go. Ultimately, it became reality. Russell's vision of the magical glass fiber.
I think there's always something going on in my head, and I'm always thinking about something, even when I think I'm not. Yeah, it's the way it is. If you like doing research and you like this kind of work, it never really leaves your head. Because you're always thinking of something that maybe you didn't quite grasp the first time.
For Philip Russell, home is the ideal retreat. Music is his passion and a source of inspiration. Of course, his family is there to give him courage and strength.
He's interested in a wide variety of things, and I think that all contributes to how he thinks about things, both in music and in physics.
How absent-minded is the professor then?
Says quite a professor, the absent-minded professor.
Oh yes, he can be absent-minded, certainly,
Am I?
yes. Oh,
And
yes.
what does son Jossie think?
Jossie?
Perhaps.
Don't say yes.
Okay.
But one thing is for sure.
He's inspiring, I think. Ja, ich bin sehr stolz.
I've often said I'd like to have 3 or 4 lives and not just one. Yeah. That'd be great. You could do 5 different things. Maybe just one more would be good. And live it in parallel, you know, be a musician and... Sadly, you can't do that. There was never enough time for everything.
Maybe the last word hasn't been spoken. Who knows what ideas Philip Russell might come up with next?